folks. Let's kind of get things started here. So hopefully you guys saw from the snow day that I picked Thursday for the test day. So the test isn't right now. Cool. Shock, surprise, it is. No, I'm joking. So I want to spend a few minutes here, at least kind of talking about test format and taking some Chapter 9 questions. Hopefully you guys spent some time over break and finished up your problem set and you did the review packet. I think all that stuff was what I asked you to do for the snow day. But I figured we should make some times for questions and talk about some test format stuff. So the test is just 7 questions, but I mean, might as well be like 20 because most of them have, like multiple parts to them or 30 or whatever. There's a lot of parts because most of these questions are not like tremendously time consuming as you saw from the homework, right? So again, like you should be able to calculate the lengths of segments inside 3D figures and the angles inside 3D figures, and should be able to do surface area and volume for 3D figures and like 3D compound figures. Like if you took a cylinder and put like a hemisphere on each end of it and made it look like a pill or something, should be able to do like a surface area or volume for something like that. There are like 2 big multi-part questions, kind of like the last 2 problems on the homework set where it's like, you have like A, B, C, D, E, F, and some of the questions depend on the previous stuff. And then the equation sheet for this is pretty extensive. If you haven't looked at the review, the last page of the review sheet is the equation sheet you get for the test. So if it's not on there, it should be something you would want to have memorized. But I think for the most part, like everything that you would commonly use is on there. But is that we feel okay about the test format here? This one, it shouldn't be like much of a surprise as to like all the problems are kind of the same, just like you got to see the triangle is the hardest part. But I do want to make some time though, if you guys have questions from homework or the review or any of that kind of jazz. Let's take some of those. Rita? 22? Sure. Grab that. Okay. Drop that in. So this is the one you're talking about, right? Okay. So it says the diagram below shows Farmer Neal's garden shed. The cross section of the shed is a pentagon. BCD and IHG are isosceles triangles. So that means that like BC and CD are the same length as is IH and HJ, or G, excuse me. The following lengths are also given, that AB is 2, so that should be the same thing as DE, NGF, and IJ, since it was a regular figure. And then we're told AE and BD are 3, so this is 3, this is 3, JF is 3, IG is 3, and then EF and DG are 5, so EF, DG, as is AJ and BI. It says the perpendicular heights to point C and H, so that's this distance down to the ground, is 4.5, and we're going to calculate the volume and the surface area. So the volume for the shed, I'm going to do the volume of the prism well, we should say output rectangular prism plus the volume of the triangular prism. So I'm just going to break it into two pieces, the box and then the wedge that's on top of it. So the area for the rectangular prism should be pretty easy. It's just going to be like length times width times height or whatever. Right? We have everything we need to do that part. And the volume for the triangular prism shouldn't be too bad either, because we know that this distance here from the height of that triangle is, this distance is 2, and we know up to there is 4.5, so that's 2.5. So the area of the base is 1/2 3 times 2.5 times the height, which is 5. Yeah, catching the 2.5 is like basically given to you. Is maybe not super easy to see, but like once you see it, you're like, yeah, that's how you do it. So there's my volume. I'm going to let you guys grind the numbers out, but like, who cares after this point? Like, that's a calculator problem. The surface area, we're going to approach the same way. So we'll do the surface area for the rectangular prism plus the surface area for the triangular prism. So for the rectangular prism, I got the front and back. So we have 2 of those. And then we have the sides. We have 2 sides. And then I guess we're counting the bottom. Do we count the bottom? It's a shed on the ground. Braden says yes, the answer, if you want to get the answer in the back, you need to count it. But we don't count the top because the triangular prism is sitting on top of the top. So that's why that one's not multiplied by 2. And then the triangular prism, I have the triangle part. So 1/2, and then the triangle was 3 times 2.5. And then I have the 2 rectangles on top. Now, the catch here is we don't know that length, right? We don't know CD yet, so we're going to have to do a little calculation triangle to do that. So I'll just call that point M there, so I have something to label it. So I know that this is 2.5, and I know MD is going to be 1.5. Very good. Since it's an isosceles triangle, I know that height is a perpendicular bisector. So that side is 3, right? So I can just Pythagorean theorem that up. So I have 2 of these that are the square root of 2.5 squared plus 1.5 squared times 5. And that'll should be my surface area there. And again, I'll let you guys calculator that, but that should do it. Feel okay? Yeah, no problem. Do we got some others that we want to talk about from the homeworks? The surface area ones are sometimes tricky because there's a lot of, you got to make sure you get all the parts. Giselle? 12? Sure. Okay, so it says diagram shows the cylinder with radius 20. The height of the cylinder, BD, is 60, and C is a midpoint. So that tells me that, like, those are each 30, right? And asks to find the angle or the value for angle X and then the value for angle Y. So the pink triangle that they've drawn in for us, what do we notice about this thing? It's not a right triangle, right? So we could use this, and you could use the pink triangle, and you could use the law of cosines to do this, but you don't have to. We have enough information to use just right triangle trig, which is probably what I would do. So finding the angle X, what I'm going to do is I'm going to find the angle DAB, and then I'm going to find the angle CAB and just subtract those. Because that way I don't have to use any non-right triangles. So what is that? It's going to be angle DAB minus angle CAB. Does everybody feel okay with what I've done there? So just off to the, well, we'll just do it underneath, I guess. So DBA is a right triangle. This is 60. This is 40. So that's not, I didn't draw that right. This was supposed to be the A and this is supposed to be the D. Okay. So angle DAB is going to be the tan inverse of 60 over 40. Easy enough. And then angle CAB well, this is still 40, but this is now 30. And then we're just subtract those two and we're good to go, right? Does everybody feel okay there? Giselle, you're happy with what I did? Okay. Let's talk about angle Y now. So again, I could find angle Y using law of cosines or law of sines or something, but like I don't need to use that. I could just use right triangles. Because I noticed that angle Y is the a different color, is the linear pair to angle ACB. And what's even better is because I already found angle CAB, I know that angle ACB is just going to be 90 minus angle CAB, which I already found over here when I did X. So just not too bad. Now, you could have done this using law of sines and cosines. I would not. I would do it this way because, boy, howdy, that seems way simpler to me. But you could. This wouldn't be wrong. But I'm a right triangle guy. If I can get away with just doing right triangles, like, sign me up for some of that. Giselle, does that make sense?
Yeah.
Yeah, you're welcome. Did you try to do law of cosines or something and get kind of lost in the sauce?
I like knew how to do how to find X, but like I just was so lost on Y.
Oh yeah, catching that it's a linear pair with that other angle is the trick there to make it like real easy.
Mm-hmm.
You're welcome. That geometry, previous knowledge coming back to bite you. Ah! You know, maybe not. Tessa, 10? Sure. All right, let's see. It says VABCD is a right pyramid on a square base. VO is the vertical height of the pyramid. The length of each side of the square base is 30 or is 26, and the slant height, that is VC, is 38. And we want to find the value of angle VAC. Okay. Well, first thing I'm going to note is that the angle VAC is going to be the same as like VAO, right? Do you agree with that, Tessa? Right. That should be kind of obvious. So let's kind of start drawing in what we have. So I know VA is a slant height, right? If this is a right square pyramid, VA and VC have to be the same. Since O is at where the perpendicular, the height, I'm sorry, is where the height of the pyramid hits the base, I know that's perpendicular to the base. So I know that's a right angle. And we're looking for this angle here. I'll just label it X. Now, what I'm going to do is I'm going to find AO first, and using that answer, I'll then calculate X. Is that cool? Okay. So I know that AO is going to be half of AC. And I know since it's a square, those are both 36. So if I use the Pythagorean theorem, that's going to be 26 root 2 for AO. So then angle VAO is going to be the cosine inverse of 26 root 2 over 38. Does that feel okay? Okay. And again, to get that, I just did the Pythagorean theorem and simplified. Or I used my special right triangle 45, 45, 90 triangle definition. Either one is appropriate. It doesn't matter. I actually used the second one to get it quickly. But they give you the same thing, right? Does that feel okay? Okay. Cool. Any others? Happy to do more if you guys got more. Rita?
31.
Sure.
So starting at D.
Yeah, I'll probably have to just start from the beginning because I think I probably need parts from, you know what I mean?
Yeah.
Like parts from A, B, and C to be able to do those other ones, but we'll see. All right. So it says that we have some box here with dimensions 2x, x, and y. And we want to show that y is equal to, and the total length of all 12 edges is 48. So this is what I'm going to be using to do part A. So if I look at the picture, I'm going to have 1, 2, 3, 4 x's. And then I'll have 1, 2, 3, 4, 2 x's. And then I'll have 1, 2, 3, 4 y's. And when I add up all those sides, I have to get 48. So 4x plus 8x is 12x. I'll just subtract that over. And then divide by 4. That's what it asked me to get, so I got it. Yay! Show that the volume of the container is this. Okay, well, I know the volume is length times width times height. So that's going to be 2x times x times y. But I'm not going to use y. I'm going to use 12x minus 3x because I look at my answer and there's no y's in my answer. So I'm just going to write y in terms of x, which I did in the previous part. And that's what I was supposed to get, so we're good there. It says find the x for which the volume is at a maximum. So to do that, I'm just going to graph the volume function that I just written on my calculator and look for a maximum. So a couple of things. What values of x are going to be reasonable? Got to be positive, right? Additionally, they also have to be less than 48. Since you know that the sum of the side lengths is 48, you certainly can't have an x that's longer than 48. So I'll just go like, 0 to 20 or something should be plenty. And then again, I know my y's, I don't care about negative volumes, I only care about positives. And I don't really know what the upper bound is going to be. I'm just going to put 100 there for, for the sake of it. And if I have to adjust, I have to adjust. But it doesn't look like I do because that looks like my maximum right there. So second trace, use the maximum command. Move my left bound. I can see that it's like way down off the screen, so I just have to keep moving. There, I see my little cursor. That looks good. Right bound over there. That looks good. Press enter. I get about 2.67. And then what unit? These are in meters, right? D says find the maximum volume for the container. Well, I have that right here. The y is the volume, right? I graphed v equals 24x squared, so the maximum volume is that 56.89. And then it said, oh, what did I do here? Find the x when should find. Okay. Oh, there's no c. Okay, that's why I'm confused. I was like, where? What? Where did c go? I don't know. You ever mislabel something? Happened to me. All right. It says find the length of the height, or the length and height of the container for which the volume is maximum. Well, I know the width is equal to x, which is 2.67. I know the length is equal to 2x, so that's going to be whatever 267 times. Oops. 267 times 2. So 534. Shame I couldn't do that in my head. And then the height was equal to y, which was 12 minus 3x. Okay. 12 minus 3 times 2.67. So 399. And that was F. And the last one, G, says the shipping container is going to be painted. 1 liter of paint covers an area of 15 square meters. Paint tins come in 4-liter tins. Calculate the number of tins required to paint the container. So I'm going to start by calculating the surface area. So I know I have 2 length times widths, 2 width times heights, and then 2 length times heights, right? So just using my answers from before, I have 2 times 2.67 times 534 plus 2 times 2.67 times 399 plus 2 times 5.34 times 399. So I got about 92.4 square meters. So if I divide that by 15, because I know 1 liter of paint covers 15 square meters. Tells me I need 6.16 liters. And since the tins come in 4 liters, I know I'm going to need 2 tins then. So I have some left over, but can't do it with 1 tin. Does that feel okay? Sure thing. Oh, it looks so easy when Mr. Gulick does it.
Yeah.
It's a gift. Elena.
In number 3A, was asked for dimensions. Is that just like height and width?
Well, since it's a cylinder, it would be like radius of the top and like of the base, and then like height of the cylinder.
Oh.
But yes, that's what it's asking for, just like some measurements. That does it?
Yeah.
Okay. What do you guys think? Is this looking okay, Giselle? Are you gonna have to what?
Do something like number 31.
Yeah, for sure. For sure. I think that's what I said, is that I have like, there's 2 kind of big multi-part questions, like these last couple of questions in the homeworks, where it's like a little bit more involved and the parts play off one another a little bit. What do you guys think? We okay? It's all right. It's all right. Okay. If you have more Chapter 9 stuff that you want to talk about, feel free to come back and talk to me. But if there's no other questions here, I'm going to start a little bit on Chapter 10 today. Okay. Is anything I do in Chapter 10 going to be on the test on Thursday? No, because what's the Thursday's test on? Chapter 9. All right. So, chapter 10, we're going to be talking about parametric functions, or start by talking about parametric functions. And this is a lot of fun. So I'm going to start by just kind of motivating this a little bit of what we're doing. So if I look at something like this, is this a function? It's the graph of x squared plus y squared equals 1, a circle. Is that a function? Okay, you guys say no. Why not? Okay, doesn't pass the vertical line test. And what is that? What is the vertical line test telling us? Like, I understand that's our explanation for why it's not a function, but like, what about our definition of a function is this failing?
For every answer is more than one y.
Yeah, so I'm gonna change those. That's great. I'm gonna change that. Instead of saying x and y, I'm gonna say input and output, right? What if I wanted to now, what if I want something like a circle to be considered a function and still meet that definition that every input can have only one output? What would that function need to look like? Well, I would need some parameter as my input, and it would have to output an ordered pair. Right? My function could no longer depend on x. It would have to depend on something else, right? Not x or y, not any of the points I'm going to plot, but some other parameter, some other variable. Is everybody okay with that idea? Now, if I do that, I can end up with a graph that fails a vertical line test, but still could be considered a function because it is no longer defined in terms of x or y as the input, but as some other parameter. We call such a function a parametric function. So let me drop in here the definition. So we say that a graph of ordered pairs, so it's a bunch of x, y's, where x is some function of t and y is some other function of t, our functions defined on an interval I is called a parametric curve. The functions f of t and g of t are the parametric equations for the curve. The variable t is the parameter, and I is the parameter interval. So let's take a look at an example of kind of what this looks like, right? So let's say we have some function. So this is an example of a parametric function. We have x defined as t squared plus 1, y is defined as 2t, and the t's that we're considering are those between -3 and +1. So if I wanted to graph this, I'll make like a little txy table, and I'll just pick some values of t, and I'll just pick easy to do whole number values of t, and then we'll plug those in. So -3 squared is 9, plus 1 gives me 10. 2 times -3 gives me -6. And we'll just kind of continue going through and doing that. Does everybody kind of get how I'm doing this? So I have here 10, -6, 5, -4, 2, -2, 1, 0, and then 2, +2. So it kind of looked like that, right? Now that's graphing it by hand. Do you suppose we're going to graph these things all by hand? Guess what your calculator can do? They can graph parametric equations, yeah. So let's show you how to do that. So to do that, you're going to have to start by changing the mode of your calculator. So press the mode button. And if you have your calculator with you and you want to follow along and kind of get used to doing this, I invite you to do so. If you just want to sit and watch, that's okay too. No big deal. So what I'm going to be doing is I'm going to be changing the mode of my calculator. Currently, my calculator is in function mode. The PAR option is parametric mode. We'll talk about polar functions a little bit later this chapter. That's the POL. And the SEQ is for sequential, for sequences. We don't do that here. But I'm going to change that to parametric. So now if I go and hit y equals, whoa, this looks really different now. My y equals menu has x1, y1. And notice there's a t there telling us that this is, the equation is in terms of t. So if I press the variable button, notice the variable button has x, comma, t, comma, theta, comma, n. Depending on the mode of your calculator is going to just automatically change the name of the variable. So if I press that button, I get t's now, since I'm in parametric mode. So I'll just type in t squared plus 1, and then 2t. Everybody feel okay so far? Okay. Now what I'm going to do is go to my window. So if I want this to graph, it has to graph from t equals -3 up to t equals 1. So that'll be my t min and then my t max. And then the rest of this stuff, I'll probably just reset this to standard window. So just -10 to 10. Since I jacked it all around when I was graphing that other problem just a few minutes ago. And then let's hit graph. So there's that. It's okay. What if we had changed this, and instead of graphing it from -1 to 1, what if we then graphed it from -3 to 1? If I did from -2 to 1, or -2 to 2, excuse me. What's going to change here? Well, I'm going to lose these points off the end, right? And it'll extend one more point in this direction. So like I'd end up, if I plug +2 in, that's going to be 5. 1, 2, 3, 4, 5. And then 4. Right? So I end up with something like that, where it extends it a little bit, but I lose a little bit off the end. Let's just check that. -1 and then 2. Hit graph. And that's indeed what I see there, right? Oh, -1 even. Sorry, I did -2 there. You guys kind of see what's happening? Can we guess what the shape of this thing would look like if we just did it for all real numbers, for t being -infinity to +infinity? What's it looking like? Like a sideways parabola is what I think. So I'm just going to make this just like -10 to 10, just something big that'll fill up the screen. What do you guys think? Is this okay? Let's do some more examples. So let's say we have the parametric function where x is defined as sine t and cosine is defined, or y is defined as cosine t. What am I missing, though? The interval of which we're going to graph this, right? What would be a sensible interval for this? What do you guys think? What do we know about the values for sine? Well, the output, sure. But what do you know about, like, so think about, go back to first semester. Are the values for sine all different? No, they repeat, right? How often do they repeat? Every 2 pi, right? So if I go around the unit circle, 2 pi, all the values are just going to repeat over again, right? What about cosine? Same thing. What would be a good interval to graph over then? 2 pi, right? Now, So our x-coordinate is going to be sine, and our y-coordinate is going to be cosine. Anybody know what this picture is going to look like? What's that? It is going to be a circle. How did you know that? You guessed. Okay. Go back and think about first semester. Think about the unit circle. What are the coordinates on the unit circle? Cosine theta comma sine theta, right? Is it going to make a different shape if I switch sine and cosine? If I just switch the coordinates of the unit circle? It's going to be the same thing, right? Oh my goodness. Let's hit graph. Oh, look at that cute little unit circle it drew in there for me. Okay. So we have this new way that we can represent functions, right? We have this new method called a parametric function. And then we have our old way of writing functions. We call that the Cartesian form. What do you suppose we're going to talk about doing next? Translating back and forth between them. So to go from a parametric function to a Cartesian function, the direction we give for that is eliminate the parameter. So what do we call the parameter in this case? T, right? T was the parameter. So what I'm going to do is I'm going to take my equation for x, and I'm going to write that so that the t is by itself. So subtract 2 from both sides, divide by -3. So I pushed the negative sign up into the numerator. That's why things switched order. Just because then I don't have to write an extra negative sign. It's fine to write a -3 down there and keep the order the same as it was before. Everybody's okay with that? And now I'm going to take my equation for y and substitute in my value for t. So I'll go and push the negative sign through. And then I'll make a common denominator and add my fraction. And then I'll just rewrite this. And what do you see here? What type of graph should we be getting? It's a line. Woo! That's cool. Let's just check, right? Let's graph the parametric and see if it matches. And again, I can't type in -infinity to +infinity on my interval. I'm just going to type in -10 to 10 because it'll fill up whatever space I have here. Well, that sure does look like a line with a y-intercept of 1/3 and a slope of 1/3, don't it? That's pretty neat. That wasn't hard, Mr. Kulik. Just like a little bit of algebra. The thing that we have to be careful about is the domain and ranges. So we have to make sure that the domain for this and range match the domain and range for the parametric. So before we say we're done, we need to check that. So if I go back to my parametric, my input is anything from negative infinity to positive infinity, right? What values of x can I have if I can input negative infinity to positive infinity to that equation? Negative infinity to positive infinity still, right? If I take anything and I just do a linear function to it, I can get anything back. Everybody agree with that? Okay. So the domain here is all real numbers. What if I look at the range? Again, my inputs can be all real numbers. What are the values for y that I can have? Also all real numbers, yeah. So do I need to make any adjustments to my function? Because when I write f of x equals 1/3 x plus 1/3, what's the domain for that? All real numbers. And what's the range? Same thing. So it matches. So I don't have to do any adjustment here. Everything is fine. Does everybody kind of see that? Let's do an example where everything is not fine and we have to do a little bit of adjustment. All right. So here is my problem. It says eliminate the parameter. I'm going to start the same way. I'm just going to take x and write it in terms of t. I'm then going to use that to plug back in or into the equation for y. What type of function do we have here? Anybody? It's an Algebra 2 question. We should be able to identify that on site. What's that, Braden? Did you have it? You don't know? I thought you mumbled something. Give you a hint. Starts with a Q. Quadratic. How do you know it's quadratic? It's an x squared. It's a polynomial of degree 2, right? Everybody's cool? It's like, oh, yeah, I knew that. Sheepishly. Now, what we have to be careful about here, though, is that if I were to ask you just the domain of that quadratic, you would tell me all real numbers, right? The domain for any polynomial is all real numbers. That's not the case here, though, because the domain for this quadratic has to match the domain for the parametric that we started with. So if I look at the parametric that we started with, my inputs only go from -2 to 4. So my smallest x I can get, or my biggest x I should say, is 8. And the smallest x I can get is -16. So the domain should be -16 to 8. Is everybody okay with that? Why didn't any of the parts in the middle matter? Why didn't I have to worry about any of the numbers between -2 and 4? Why did I just have to check the ends? Well, if I look at the function for x, what kind of function do I have for x? X equals -4t. What kind of function is that? Oh, come on, guys. Starts with an L. Linear. Great. Now, what do I know about a linear function? It's always either increasing or always decreasing, correct? Everybody agree with that? If I have a function that's, we call those kind of functions monotone if they're always increasing or always decreasing. If you have a monotone function, all you really care about are the endpoints of the interval because your biggest and smallest value possible are just going to come off the ends. If it's always getting bigger or smaller as you go. Everybody's okay with that? Okay, let's do the range now. What type of function is my y? Quadratic. Is that monotone? No. In fact, at one point it switches from being increasing or to decreasing or decreasing to increasing, right? So I'm actually going to have to care about 3 values. What 3 values am I going to have to care about for this y? I'm going to have to care about the endpoints of the interval, -2 and +4, and also that point where it switches from increasing to decreasing or decreasing to increasing. In a quadratic, what's the special name we give to that point? Starts with a V. The vertex, very good. Who remembers how to find the vertex for a quadratic equation or a quadratic function? The equation to find the x-coordinate for your vertex is -b/2a. And then the y-coordinate is just like f of -2/b, or -b/2a. Okay. So we need to do y of -2. Well, what is that? That's 9. We need to do y of 4. And what is that? 633. And then we need the vertex. So my t value is going to be -b/2a. What's the value for b on that quadratic? 0. What's the value for a? 2. And what would the c be? 1. Right? Everybody remember the coefficient of the quadratic ABC? A is the quadratic coefficient, B is the linear coefficient, C is the constant. So this is 0. Everybody's okay with that? Now, is that vertex always going to matter? When might it not matter? if it doesn't lie inside the interval for t. Now I can see that 0 is clearly in the interval from -2 to 4. So we do need to check that. So y of 0 is just going to be 1. Everybody's okay with that? So my range then should be 1 to 33. So if I was thinking about the graph of y, this is like y of t is that function there, or there's like a t comma y of t graph. That's what it looked like, right? This is the 9, that's the 1, that's the 33. Is everybody okay with that? So what this tells me is I go back here and I have to list the domain for this function. As well. Because the domain for my Cartesian has to match the domain and range for my parametric. This is kind of the hardest thing in this chapter. To say they're the same function, then the domain and range have to be the same, right? That's the hardest piece, is getting all that stuff to make sure it matches. Okay. You'll do that in the homework, and I'm sure you guys will ask questions about it again, and that's totally fine. I think it's the trickiest thing you have to do, because you really have to like wade through, like, okay, where am I at? Which equation am I using? Which one is giving me what information? You know, it's a lot of complexity to kind of step through, and if you don't really understand what this parametric function is kind of describing, it can be pretty tricky. So it just takes a little bit of time and practice, but you guys can do this. Again, especially if Mr. Kulik is sitting here telling me that this might be the hardest thing that we do in the chapter, that's not so bad. Okay. Here we're asked to eliminate the parameter. Oh, Boise. I don't like to look at this at all, Mr. Kulik. What's freaking you out here? I mean, for me, it's the trig-ies, right? How am I supposed to get the t by itself to where I can plug it into the other one and have it do anything for me? Right? If I try to get the t by itself for x, I have t equals cosine inverse of x over t over 3. I'm sorry, x over 3. And I plug that back into the other one, so I have 3 sine of cosine inverse of. That doesn't look appealing to me. It's got to be some other way here. There is. What shape is this graph going to be? It's going to be another circle. Who remembers the equation for a circle from geometry? X minus h squared plus y minus k squared is equal to r squared, where hk is the center and r is the radius. Does that ring a bell? Again, that'll be useful. You'll use that throughout this chapter. That's one of those that you'll want to make sure that you remember. Just like the equation for the vertex for that parabola. That'll come up quite frequently. Okay. So the circle that we're going to generate from the parametric function x equals 3 cosine t, y equals 3 sine t, where's that centered at? Where's that going to be centered at? Still going to be 0, 0, right? If all we're doing is like a factor of cosine, factor of sine, well, it's still got to be centered at 0, 0 because we're still going to be like the same factor, you know, it'll be fine. It'll be fine. So if I have then x squared plus y squared, that's 3 cosine t squared plus 3 sine t squared. And if I square that, that's 9 cosine squared t plus 9 sine squared t. And I factor the 9 out, because that's in common to both of them. And aha! What do you notice here? Yes, cosine squared plus sine squared is 1. Very good remembering your identities. Oh no, Mr. Kulik, do those still matter? Yeah, of course they still matter. So what do we end up here saying? X squared plus y squared is equal to 9. So we have a circle with radius 3. Because 3 squared is 9. Well, that wasn't so bad at all. What if we wanted to go the other direction? What if we want to take a Cartesian and go to a parametric? We'll start with something easy. So what kind of equation is this? Linear, right? Does this function already have the x and y separated? Yeah, right? The y is all by itself. So the parametric function I'm going to have, I'm just going to let x equal t. So y would be 3t minus 2. That's it, Mr. Kulik? We need one more thing still, but we've done the hard part. What thing do we still need? The interval, very good. The interval for t should be the same as the domain for our original Cartesian function, because we've just said x is equal to t. What's the domain for that linear function? All real numbers. So what's the interval for t going to be? All real numbers. And we're done. There's like almost nothing to do. Oh, piece o' cake, right? Well, I mean, yeah. I mean, if it's like that, are they all going to be like that, Mr. Kulik? Well, I don't know. What if we do this? What if we ask you to find the parameterization? So the parametric equation for the line that passes through the points 3, 9, and negative 5, 2. What's one way you could do this? You could write the equation for the line that passes through these points, right? Using like slope intercept or point slope or whatever formula you liked, and do the same thing we just did. Or we could do something else that I think is even easier. What I'm going to do is I'm going to write my vector equation for a line. So remember, V is going to be the head minus tail rule, right? But we have to swap them. No, we don't. Never mind. I lied. I'm dumb. We're not doing that. And R naught could just be either of my two original points. I'm just going to pick the first one. Right? And if I just add those vectors and do the scalar multiplication, I'd say this, right? Guess what this is? That's a parametric equation, right? Done. Isn't it nice when something that we did from a previous chapter just like circles right back and it's immediately applicable to something else? That's awesome, guys. Now, we do need one more thing, right? What do we still need? Yeah, an interval for t. Since this is a line, what's the interval going to be? Yeah, just all real numbers again. Should make a point to put that. But that was real easy. Will this ever be more difficult? Well, what if I ask this question instead? What's different about this question than the previous question? Yeah, it says segment. What's that mean? It's just going to mean that our interval isn't going to be all real numbers. Everybody okay with that? Now we're going to start still the same way. So we're just going to write our vector line equation. So negative 1, 4 plus negative 7 and then 7t. So negative 1 minus 7t and then 4 plus 7t. And here is the very best piece of this. Because if you're using a vector line equation to do this for a segment, your interval is always going to be either 0, 1 or negative 1, 0. All we have to do is check. So if I plug 0 in for t, my x is -1, and my y is 4. If I plug 1 in for t, my x is -8, and my y is 11. That's not right. But if I plug -1 in, I get 6, -3, so it's going to be this one. We will continue talking about this next time. Actually, that was the last example in this section. We'll continue talking about parametrics more next time. You guys have a great day. Don't forget what happens on Thursday. Chapter 9, toast.